Recently, we've been looking at different search algorithms like linear search and binary search, and I wanted to take just a minute to show you some search capabilities that are available in the standard template library, available in the standard C++ libraries. Specifically, it's common to want to be able to search for a portion of a string or a substring within a larger string. So you might want to know if some particular zip code is in an address or something like that. Another common search is you have a list of items. In our case, we'll keep it simple and just use a list of integers, and we might want to know if a particular integer is in the list and maybe where in the list is it. Let's take a look at a couple of those examples. We'll start out with some pretty standard includes and a main function, and in particular we'll start looking at the string search capability. So if I create a string that maybe is the title of our course or course number, and then create a substring to search for maybe the actual just the number part of it, how can I find that? Well, it turns out that C++ has a search capability they call find. So this is string find method, and if you give it a string and the default starting position at 0, it will return, and this is kind of an odd type. The size t is like a large unsigned integer that's appropriate for array sizes or string sizes. So you can think of this as an unsigned integer, an integer that just ranges from 0 to something pretty large. And this will be the location where it's found. And there's a little bit of a odd twist to this in that if it's not found, it returns this odd thing called string in pos. And this just happens to be a -1 value, but in an unsigned integer it ends up being a really large value. So if it's an unsigned integral type, it's the largest possible representative value for the type. So it's just a constant that allows us to check to see if it's not found. That's probably the easiest way to think of it. So using this, it's fairly easy then to do a search. We could use size t, or we could use the auto keyword, and we want to find the substring within the string. And if the index is not equal to this string in pos constant, that means we found it. Else we didn't find it. So if we find the string, we could just print out a message that the substring was found at a particular instance. And if we don't find it, we can just print out a message that it was not found, and then maybe print out the string that we were searching for, something like that. So again, this is a key thing. It looks for this substring within this larger string and returns the index where it was found if it's there, and if it's not found, it'll return this string in pos constant. Keep in mind that this search is going to be case sensitive. So in our case we're looking for digits, but if we were looking for letters like IS or something, it's going to be case sensitive. So if you want to do a case insensitive search, you would have to convert both of these strings to either all lowercase or all uppercase if you wanted to do a case-insensitive search. Also keep in mind, as we know, the indexing in C++ starts at 0, so the 295 is found at index 4, so that's 0, 1, 2, 3, 4. That gives us the location where it's found. The next example we want to look at is being able to search within a standard container like a vector. So if I have a vector of, say, even numbers here, and I want to search for something inside a particular target value inside, then we do this with the C++ find. It's somewhat similar, but it works a little bit differently. Here is the standard find, and it's in algorithm header file. And what you do is you pass in iterators over a range that you want to search for, along with the value that you want to search for. So the vector object has a beginning and end iterator that we can pass in, and then the target value is what we want to search for, and it returns an iterator. So that's a little bit different. Instead of returning an index, it returns an iterator. And the reason for that is the vector class may be implemented as a dynamic array, but some of the other containers may be implemented as a linked list or some other type of data structure that doesn't have an index. It's not doesn't have random access capability like an array or dynamic array does. So it returns an iterator. So this takes a little bit of getting used to, but it's not too bad. So you can use the auto keyword and create an iterator variable and say find in the number list starting from the beginning and continuing searching in the number list to the end, and look for the target value. And if it's not found, it's going to return the end of the list. So the return value is an iterator to the first element that matches, or if no elements match, it returns the last, or in this case, what we passed in was the end of the list. So if it is not equal to the end of the number list, that means we found it. Otherwise, that means it was not found. So we can do some output to tell us that it was found, and we might, if we want to know the location, we have to do something a little bit different. Remember that the thing we get back is an iterator, and it's not a index, but we can convert an iterator to an index because they have a subtraction capability. They have addition and subtraction overloaded for iterators. So if you take the iterator of where it was found and subtract the iterator for the beginning of the list, then you'll get the index where the target value was found. Otherwise, if it's not found, we can print out a message here that says the target value was not found, and after the if-else block, we can print out the list. In the list, a range-based for loop for each number in number list, and then print out the number separated by commas. So if we run this again, the 295 was found at index 4, and then the 6 is found at index 2. So 0, 1, 2, remember it's zero-based indexing. And so we're able to successfully search for a substring within a string using the string find method, and we're also able to search for a particular value within a vector or other container using the standard find function that's in the algorithm header file.